explore the biggest questions of our time, and get to know the people behind the science. This is Curiosity Meets Discovery, research talks from inside the Max Planck Society.
We live in unprecedented times. These words have been spoken over and over again to describe our society's experience with COVID-19, an experience that has changed every aspect of our lives. But the pandemic is only one example of how our way of living can be dramatically altered in ways we couldn't imagine, and with a lasting impact that remains uncertain. Staggering leaps in technology, such as machine learning and AI, are clearly changing our lives, and at the same time, generating huge uncertainty about the jobs of the future and how to prepare for them. Today's guest is a scholar who specializes in making sense of the dramatic changes to our world, everything from the implications of automation to the far-reaching technological trends that will result from COVID-19. Dr. Alex Rutherford is a senior research scientist and principal investigator at the Max Planck Institute for Human Development in Berlin. He received his academic training at Warwick University and University College London, and has also worked as a data scientist in UN headquarters in New York. More generally, he is an experienced applied researcher drawing on a background and training in physics and data science to understand and model diverse social systems that sometimes seem to defy understanding. His projects are diverse. There's one theme that ties his work together: change. Using scientific principles, Alex strives to make sense of the swirling winds of change that move our world forward, and to help us prepare for the impacts of unprecedented circumstances in our future. Alex, welcome to Curiosity Meets Discovery.
So the title of my talk is Myths about Automation and Predictions for Post-COVID Work. So this is a very accessible walkthrough of the work that I'm doing at the Max Planck Institute for Human Development in Berlin. As you will see, this is a very interesting and difficult and nuanced area to work in. Lots of people are talking about it. And really, we're trying to bring everything we can to try and understand it better. So it's very much interdisciplinary work, and I hope that will shine through. All right, so when I am not a senior research scientist, I like to take low quality mobile phone footage of automation technologies when I'm traveling. So the first one you see here is taken at a train station in France. And you'll see this is one of these sit-in cleaning devices, and it doesn't have anyone sitting in it, it's autonomous. And you can see it does a pretty good job. It's able to clean this sort of big open area. It can avoid the wall, it can avoid other passengers. So that's pretty much a successful deployment of an automation technology. So what this really gets at is the first myth I want to kind of shatter, which is this idea that robots make jobs obsolete. And that's not really quite the right way to think about it for a few reasons. Labor economists think about jobs as bundles of tasks. So tasks are things that we do in our jobs. And in my job as a senior research scientist, I read papers, I write papers, I give presentations, and these are the tasks in my job, and they're all grouped together, and that's what my job is. So what can happen is some of the tasks come out of that job if we no longer need people to do them, or if they're taken over by other jobs. So that bundle of tasks is not really fixed, even if the title remains the same. And what we need to understand is that automation and technology tend to target these individual tasks rather than the job as a whole. And we wanted to get a little bit closer to this question, this kind of precise idea of how long it takes for an occupation to actually disappear. So the canonical example here is a elevator operator. So if you think about those, lovely Art Deco buildings in Chicago and New York, in the good old days, you would go in and a gentleman, it was more often than not, a gentleman would operate the elevator for you, and that doesn't exist anymore. We wanted to answer this question a little bit more systematically, away from kind of this sort of anecdote. And if I had the genie's lamp that I could rub, I would ask for a pristine, beautiful data set that records all of the occupations that were available in the US. I'll go into more detail about why we study the US. So I would like to have this pristine data set that covers many decades that I could just sort of quickly analyze. Unfortunately, life is not that good. And so what we have is the Dictionary of Occupational Titles. The Dictionary of Occupational Titles, or the DOT, is a catalogue of jobs that was produced by the Bureau of Labor Statistics. And there was 5 editions between 1939 and 1991. The BLS sent people out to workplaces, interviewed them, and asked them what they did in their jobs, and wrote it all down. And that looks something like this. This is an entry from 1939 for a tile setter. So you have the job title, you have this green section, which just sort of describes in words what the worker did. And we have lots of these in sort of big, huge PDFs. What you might also notice is that this is not really the most high quality print. So it's actually not even good enough for a computer to read using OCR, or optical character recognition. So we had to even get people to write these out by hand for us into a computer. But what we were interested in is really, can we use this data? Can we get it out of this analog form and use it to answer this really fundamental question of how long it takes for an occupation to disappear? So the first thing we found is jobs come and go. Up until 1949, we needed fish sorters. Since then, it seems that our fish sorting needs have been met by machines. So we no longer have that as a job. Tape librarians didn't exist before tapes, and scuba divers only came into being when scuba equipment became affordable. On the other hand, we like actors. Actors seem to be here to stay. The actor job is present in all 5 editions. So we wanted to kind of go a little bit more detail into this. So we asked, in 1939, how many of those occupations are found in the later editions, 1949, 65, 77, and 91? So you can see it sort of drops off over time. About 75% were present 10 years later, then about 25% in the later years. So the number of jobs that were present in 1939 drops off as you go forward in time. So we asked the same question for the other editions. In 1949, we can look forward, but also 1 edition back to 1939. And likewise for 1965, 77, and in 1991, we can only look backwards because we have these 5 editions. So you can sort of see that it drops off over time. Now, basically these points that you're looking at lie quite close to a straight line. And we like straight lines because it says that there's probably a decent trend there. And what this tells us is that on average, 1.67% of jobs disappear per year. And what's really interesting about this is it seems to be quite a reliable or stable trend. So from 1939 to 1991, lots of things happened. There were wars, there was changes in economic policy, people migrated, and interestingly, there was a lot of technological change. But despite all of those things, this trend seems to be quite reliable. So you might be thinking, well, what happens if the title of 2 occupations is not exactly the same, but they actually really do the same thing? So I'm not sure if you can read this, read the text here in this image. It's a sort of famous meme in the data science community that no one knows who to attribute it to. And it says, a data scientist is a statistician who lives in San Francisco. So it's making fun that this new occupation of being a data scientist is really just statistics. And we've given it a new title and now it's cool. So we would like to actually understand if there is 2 occupations that really do the same thing. So what we do, instead of matching exactly the words in the job titles, we look at the description of what these jobs do. So if I just jump back a little bit, it's this green text. And what we want to know is, are there sort of 2 job descriptions for different jobs that really are kind of the same thing between years? So we use a little bit of magic from natural language processing called a word embedding. And that's able to basically measure the distance, or the sort of semantic distance, between two pieces of text. So we can see if there's just been a change in the title of a job. So, the kind of the counterexample here is the actor. So in 1939, an actor played an assigned part or role in a production. In 1949, played a part or role in dramatic production also. 1965, portrayed a role in a dramatic production to interpret character. And in 1991, portrays a role in a dramatic production to interpret character once again. So, all of these would have very similar, very short semantic distances, because they're really the same thing. So we do a similar measurement here. We're looking at 1939, trying to find the most similar sounding occupation, looking at the later editions. You've got lots of points now because we're comparing every single job. And the blue line is just an average here. So again, you sort of see this drop off over time as we look to all of the other editions. And we can look kind of forward and backward to see if there's any difference going forward in time or backward in time. And again, we get our nice straight line. And this tells us that even when we look at the content of these jobs, not just the titles, they change by about 1.7% each year. So again, we perhaps counterintuitively see this sort of very steady, gradual trend over all of these decades. So it's actually really important that we have this longitudinal data, because it takes a very long time to deploy technology. Once we've solved the physics and we have the patents and the licenses and done all the marketing and all of the procurement and the insurance and put it into companies, and then finally start to actually replace human workers, it takes about 10 years to really see that effect. So it's, this seems like a long time, but actually it's not such a long time in terms of technological change. All right, so the second myth is the idea that a robot can do anything. And this is accompanied by a GIF that I took in a hotel in Silicon Valley some years ago. I was traveling for business and I realized I didn't have any toothpaste. So I called down to reception and I said, would you have a small packet of toothpaste I could use? A few minutes later, I don't remember exactly how, but I became aware that someone or something was at the door. And this guy arrived, and inside was some toothpaste. So, if you're a receptionist, you might be starting to get a little bit nervous and think, well, maybe I'm not going to be a receptionist for too much longer. And of course, the reality is not the case. You're not going to see receptionists completely replaced. Yes, there are lots of routine tasks that can be taught to robots, such as bringing things to your room. But robots and machines really struggle with contextual knowledge and empathy. So when I go on vacation and I go to a hotel, I like meeting someone from the local area. I like to get their tips. I like to feel like I'm having a unique experience. Likewise, people who work in hotels, they see a lot of people from different countries. They know sort of different cultural preferences, so they're able to really deliver that part of the job, and that's something that we can't replace. This is sort of systematized by a really nice opinion piece from Eric Brynjolfsson at MIT Sloan. And these are the sort of seven pieces that you need for machine learning to take over a task. So when we say machine learning, we really sort of use that interchangeably with artificial intelligence. So the first two are that it needs to be a well-defined task with a clear success metric. So, this is probably the main stumbling block for actually deploying automation in the real world, because lots of work is very hard to sort of pin down, especially knowledge work. Then we need large sets of inputs and outputs. So this is how we train the algorithm. And this really sort of gets at this idea of contextual knowledge. Many of you will probably have young children, and young kids learn very quickly. They know if they pull on this, then things fall on their head, or they touch the stove and they get burnt. Computers really need like 1,000 examples of touching something hot and 1,000 examples of touching something that's not hot, and then they can build up a picture of what's going on. At the same time, algorithms cannot really give us a reason why they made a certain decision or classified something in a certain way. So there's always going to be a need for that domain expertise to kind of dig into the algorithm and give us an explanation. That's something that we're getting better at, but it's still a problem. Algorithms are statistical, so sometimes they're wrong. And then finally, the phenomenon should not change rapidly. So, in my previous life, I worked as a data scientist at the UN, and a lot of the work that's done there is very complicated, moves very fast, has lots of actors, has lots of sort of outside influence. So if you want to understand something like conflict and try and predict it, then you really need to update those systems that you're deploying, because that's a phenomenon that changes very rapidly. So we wanted to get a little bit more at this question of, how can people think about how low-wage workers should plan their career around automation? And from this was born The Automated Life. The Automated Life is a browser-based public game that you can play that helps you to simulate what it's like to be a low-wage worker. So you can go to theautomated.life, and I encourage you to, and play this game. You begin in the role of a low-wage worker who is very likely to be exposed to automation. And you then navigate from that starting job to neighboring jobs that have similar requirements for skills. And over time, you would like to move to a stable, well-paying job so you can retire with sufficient savings to have a nice retirement. At the same time, you're being chased by robots that are constantly automating jobs and lowering their wages. So, in my previous life, I used to simulate molecules and what happens when radiation hits them. And simulation is a really nice way to put in what we know and then kind of play with the things that we don't know. And games are really no different to a simulation. We're able to put in the things that we know. In this case, we take jobs we take information and data about jobs, skills, wages, the education requirements about automations, the skills that they target, and also educational courses, how we can retrain, what kind of skills that retraining gives you, and how much it costs. This is something very nice for the US audience because we use data from the US. There's a couple of reasons for that. One is that the data quality is very good. And secondly, you can perhaps think of the United States as the fruit fly for labor economics. So in biology, fruit flies are always studied because it's an organism that lots of people know and it's very easy to compare between studies. So in general, we sort of stick with the US because that's where a lot of the studies are based and we can sort of do nice comparisons between them. This was a very fun experience, something very different from a scientific paper. And the purpose of it was to try and engage the public and for people to really understand what it's like to be a low-wage worker, because lots of us, that's something very, very removed from our reality. And, one anecdote I'd like to share is that people really sort of, I did a lot of user testing and I saw how people reacted to this. I saw someone who was very close to winning the game, or it could win the game if they sort of just clicked the retire button, but she wasn't. And I asked her why, and she said, well, look, I'm really close to being a film editor. This is my job here and I want to get there. And I've always wanted to be a film editor, so I'm going to keep playing until I win, even though this is sort of something very abstract. So it's something that really kind of hit home and resonated with people. I'm going to jump through these a little bit in the interests of time. All right, so the third myth and third GIF is that we are always waiting for technology to catch up. So this is accompanied by footage I took in an airport in Spain. And what you're seeing here is an example of a technology being deployed in order to partially automate airport security staff. This is a video recording of someone giving that typical spiel that we all know and probably hate when you're going through security, taking out your laptop, take out your liquids. And it's been recorded and it's repeated in Spanish and English. And you can even see that the projection has real trousers and real shoes. So they've even a sense of, trying to directly replace that person. I'm going to just switch to the static image because it's a little bit distracting. So, the high level message here is that actually we're not really always waiting for technology to catch up. This kind of technology is not really new. It's not really groundbreaking. It's something that could have been deployed some years ago, but it wasn't. Perhaps in the past, when we think about sort of the big technological advances of putting people on the moon or making identical garments at the cheapest possible price or killing as many people as possible in a war, we really were just waiting for technology to catch up. But now we're really in a different situation where we have lots of technology, but it's getting more and more complicated to deploy it. And that's for a few reasons. There's a lot of cultural differences that often make it difficult for us to deploy that in a straightforward and uniform way. And the kinds of automations that we have tend to be more embedded in our homes, in our workplaces, and sort of mediate our social interactions. So they tend to be a little bit more complicated and harder to be kind of accepted by people. As a result, you have a set of technologies that can automate different jobs to some extent and different skills. And really the degree to which those are successful depend on how much effort we put into each one and also things outside of our control. And in that sense, this has been a really interesting 18 months with the COVID pandemic, because we've seen a lot of interaction between sort of COVID and how that's restricted what we can do, and the adoption and the innovation of kind of remote technologies. So we wanted to kind of get at this. This is work that I did with my colleagues when we sort of saw the world changing back in March 2020. We put our heads together and thought, what can we do with our skills, our skill set, our understanding of automation and our understanding of infectious disease. And very specifically, we wanted to answer which and how many workers should be furloughed in an infectious disease pandemic. So, this is a hard problem for policymakers. And the spoiler here is that you actually only need to furlough about 20% of workers. So you only need to send about 20% of your workforce home and pay their wages to really drastically cut, first of all, the cost of sending them home for the duration of the pandemic. Secondly, the number of lost days of work due to infection. And thirdly, the peak of that infection. So that's a measure of kind of the peak demand on your healthcare services. But this is provided that you choose those workers very carefully on the basis of the structure of the contact network between them. So a contact network basically links people if they are within 1.5 meters of one another to the point that they can infect one another. So again, we work with data from the US, and we use a database called ONET. This is the successor of the Dictionary of Titles, this big sort of PDFs that I spoke about earlier. And that measures lots of things about jobs, and it includes things like physical proximity. So, we have choreographers and dental hygienists here, and they're all people, they're all occupations who are in contact with people to a large degree. So we take all of these measures and sort of put them into an index of proximity. And here we've got the top 5, they're all medical occupations, and the bottom 5, which are all kind of interestingly occupations that work with machines. So you have trimmers and dredge operators and so on. So then what we did is we built a virtual workforce. We used New York City. We used a city as our simulation space, let's say. And we took data on how many people work in different jobs in New York City and what we know about each of those jobs. And we basically construct a, let's say, a kind of virtual contact network between them. So we use all the information that we know to simulate how these workers might meet with each other and be able to infect each other. And then we're able to simulate how the disease spreads on that network. So how it goes from one through the links to each node. And then we can see what happens when we start to take nodes out. How can we choose the right nodes to take out so that the disease dies out as quickly as possible? This is a good point to talk a little bit about how we can put jobs into kind of categories. So it's generally accepted that there are 3 sort of broad buckets for jobs. So we have physical jobs, and these are the kinds of jobs that we think about a lot when we think about automation. So typically truck drivers are kind of the go-to occupation when we think about automation risk. So these are jobs that don't pay very much. They have low proximity to other people. So, you can also think about construction workers in this same bucket. And I can really vouch that construction workers have been able to work unimpeded throughout the pandemic, as I have some construction outside of my apartment block. And they can do that because it's low proximity. They're outside or in isolation. But those are jobs that are at high risk of automation, at least pre-COVID. And then you have the sort of cognitive workers, programmers, academics, and so on. And those are all jobs that have low proximity. They could work from home, generally get paid quite a lot, and they're not really at risk from automation. And then you have this sort of interesting third class, which was coined by David Otter, who's also at MIT. And he talks about wealth jobs. And these are jobs that are very much people-facing, but the work is not really cognitive. So you might think of personal shoppers, yoga instructors, beauticians, and these are people who need social skills, but they don't really do sort of hard physical work, but also not deep cognitive work. They generally also don't get paid a lot, but they have a very high proximity. And these were jobs that no one was really thinking about automating pre-COVID. So I want you to sort of have this picture in your mind. And you're probably already imagining the kinds of changes that have happened to these wealth jobs as all of the sort of yoga and fitness instruction has gone online. And we've seen a lot of innovation around remote technologies in this third class. All right, so back to our results. We were interested in what the effect was of having a sort of furlough policy of varying severity. So 0% furlough, you do nothing. 100% is the most strict. So first of all, we were interested in what's the cost of furloughing workers. So we have to pay these people's wages, but they're not contributing economically. So we can furlough all the people who can work from home. We have data on who can work from home and who can't. And that's kind of a free lunch. All the people who can work from home just go home, and that's great. Then if you do nothing, if you sort of do the laissez-faire Sweden type approach, then also it costs you nothing. Of course, that has some implications as a strategy elsewhere, but in this case, we're just looking at the economic cost of furlough. And as we furlough more and more people, it costs more and more, and it sort of rises to a peak at about sort of 60% furlough. And then, as you furlough like almost 100% of workers, what happens is you really start to become more effective, and the epidemic is cut, and those people don't need to be furloughed for so long, so it gets cheaper. So this tells you don't really want to sort of do a middling strategy, because that's going to be costly, but it's not really going to cut the epidemic. We're going to do the same thing when we think about what the effect is on people who get sick. Now, this is obviously kind of a controversial topic, that it's very subjective what the cost is of someone getting COVID. We take a very simplistic approach, and we just look at the cost to the economy of that person not being able to work if they're sick for, let's say, 2 weeks. So, of course, that ignores, the long COVID effects. It ignores the possibility that that person dies, the psychological effects, and so on. But let's just sort of focus on that for now. So if you do nothing, lots of people get COVID, and you have a big economic cost, even though you didn't have to pay them to be furloughed. If you work from home, you can cut that quite dramatically. So that's good. And the more people you furlough, the more this cost goes down. So the fewer people are infected. And then finally, we want to know what's the kind of burden on hospitals. So what's the maximum sort of percentage of workers that are infected at any one time? If you do nothing, you might see about 20% of your workforce in hospitals. So the hospitals are overrun. If you work from home, again, you have this sort of drastic drop. And this sort of peak drops off very quickly. So, this tells us we probably want to go somewhere in the middle in terms of severity if we want to balance the economic and human costs. So remember, we want all of these things to be down. Like a perfect policy would be 3 flat lines. Now this strategy is sorry, let me start again. So the results I'm showing you here are for the strategy of removing jobs in order of their essentialness. So economists have calculated how much each occupation contributes in their industry into the economy. And you may disagree or agree with their findings, but we borrow these results and we order the jobs by essentialness. And it's a pretty reasonable strategy to take as a policymaker to remove jobs in order of essentialness. We also do kind of the same thing, removing occupations or furloughing occupations based on wage. Let's send home the people who are cheapest and keep the highly paid people in work. So these are two sort of reasonable strategies. And the wage strategy performs a little bit better, about sort of 20% better than essentialness. We do the same thing, removing workers at random. And actually, that's something that outperforms both of these strategies. So, this is kind of a surprising result. You always hope that you can do better than, monkeys on a typewriter trying to type out the works of Shakespeare. But, surprisingly, two very intuitive strategies for policymakers underperform removing workers at random. I should qualify this a little bit. There's actually a very interesting non-trivial relationship between the essentialness or the wage of a worker and how much contact they have with other people. So it's not true to say that low wage jobs have the most contact with people and high wage jobs have the least contact with people. That's actually not true generally. So then what we do is we look at the network degree. So we look at precisely how many contacts in this network of infectious disease contact do people have, and we remove occupations based on that. And you see all of these curves are pushed down. So in other words, we have a much better performance. We have a much lower cost of the pandemic, defined in 3 different ways. So that's something really preferable. And we looked at a couple of deeper strategies, which are in these bottom rows that I won't go into too much detail about, but you can read about them in more detail if you're so inclined. So the implications here are very interesting. First of all, this tells us if we can know just a little bit, we know a lot about occupations, okay? But if we can know just a little bit about how much actual physical contact workers have, we can do really a lot better at controlling infectious disease and keeping the economy running while minimizing the spread of epidemics. And there's been really a lot of discussion about contact tracing apps and privacy and these kinds of issues. And what this tells us is that if you can imagine that everyone has an app installed on their phone running Bluetooth that simply counts the number of other phones running the same app in their vicinity, then we could probably quite easily get a measure of this contact network degree, the number of people I'm in contact with. And we don't need to really share much data between the phones. We don't need to know who exactly I'm in contact with. I just need to count who they are anonymously. And this seems to be a pretty good way of cutting an infectious disease. And then kind of the final point is maybe we are going to start to think very differently about what automation priorities are now. So previously we were very close to automating truck driving, but actually that's not really a priority occupation for us in the light of COVID. We want to think maybe a little bit harder about the kinds of very essential jobs that we need that cannot be or are currently difficult to conduct in a remote way. So just to kind of put this into context, this is really very interesting from the point of view of human history. We are basically reversing this trend that started in the Industrial Revolution, particularly in the UK, of people migrating into cities from rural areas to convene in centralized workplaces. And that's where tools like the Jacquard loom that you see here sort of came to fruition. And all of this density in cities is really this sort of huge success story where cities are very good at social mobility and inventiveness and raising people out of poverty and so on. And it comes with this big line of work that's shown that there's all of these increasing returns from cities. So, as cities double in size, the productivity measured in patents and wages and so on, that increases more than double. So that you have this kind of extra added bonus of all these people being in the same place. And really what we're seeing now is really a reversal of that. That's, all of a sudden people are recognizing the downsides of living in a big city. It has a lot of implications, let's say, for trends we've seen in terms of urban migration in the last few decades. So I'll just recapitulate very quickly. These are the 3 myths. Robots make jobs obsolete. Robots can do anything, and we're always waiting for technology to catch up. So that's a little taste of the work we've been doing. And I'd like to just offer a few predictions of my own. in the last few minutes. So my first prediction is we're going to see an increased personalization of people's routines. This is a really nice animation of the American Time Use Survey. So this is a survey where people are asked, what are you doing at each hour of the day? And you can see people going from work to leisure to eating and drinking, traveling, and so on. And more or less, there's two kinds of people. You work 9 to 5, or you're in some kind of education. And we've all, in the last 18 months, gotten used to having a yoga class in the middle of the day, being around to have bath time with our kids, catching up on work in the evenings. And generally, people don't like when freedoms are taken away from them. So I really think this is something that will persist. And that's going to have a lot of implications for our infrastructure and so on. Secondly, there will be a lot of demand for people with experience working remotely. So we've had this phenomenon where companies have been forced to go remote very quickly. And now they're figuring out, okay, how do we do this in a planned way? And of course, there are actually a lot of organizations that have been doing this for a long time, have been completely remote. So you even have chief remote officers. And that's kind of a C-suite role that is growing in demand. And there's really a lot of changes that need to take place in organizations for this to happen. You need to think about how do we actively manage people rather than passively just because they happen to be in the same room. And we'll probably see a lot of experimentation going on, but also a lot of innovation, at the same time. This is also kind of an interesting one, something that's quite close to my heart. I think you will see a change in the dynamics of how people collaborate on a sort of personal level. So I'm very much, from a technology and academic background, and I proudly identify as a type B introvert. And when I was doing this work at the UN that I mentioned previously, I was very suddenly in a very political environment around people who are very different, very outgoing, very strong-minded. And it was really very difficult for me to adjust to that sort of communication style. And I recommend this book very strongly to anyone who empathizes. But this has a lot of implications for kind of technology companies or companies that work with technology, because when you have these two kinds of people, very often the type A people win because they speak the loudest, they dominate the room, they have the best haircut. So we're seeing this sort of shift from synchronous to asynchronous work, from communicating in written form versus spoken form. And I believe that this will probably shift the power a lot in workforces. And I think that's going to be a very interesting trend to see. And you can think about this very clearly when you think about hybrid meetings. So some people are in the meeting room, some people are taking it from home. The best practice here, because there is a lot of best practice out there about remote work that is slowly being discovered, rather than having the meeting room with all the people at home on a screen dialing in, everyone sits at their own laptop, regardless of whether they are in the office or at home. And everyone is just an identical square on a screen. So you sort of have this real democratization. No one can sort of sit at the end of the table and walk around and kind of own the room. And then finally, I think we will see new modes of social cohesion. So not only innovation in how we communicate at work, but how we communicate with friends and family. So this is a not very well-known product called Portal from Facebook. And this was sort of deployed quietly some years ago, and it got a bit more prominence during the pandemic. It's basically a new way of video calling to your family. So instead of having a Skype meeting with your parents or grandchildren or whatever, instead of sort of using the same technology that we would for a business interview with your family, you now have this device, which is always on. It's sort of designed to be in your living space. And it's able to kind of smartly focus on where the action is, zoom in when it's necessary. And it gives you sort of a more natural way to interact. And all the time we're really fighting against these three traditional criteria for meaningful interactions that are known from psychology but are very hard to have remotely. Unplanned interactions, geographical proximity, and the ability to speak freely. So these three things are really kind of challenged. So I think there's going to be a lot of interesting adjustment on our side and a lot of innovation that's coming out of the woodwork to sort of address this new way of communicating and connecting with people. So I will stop there and happy to discuss any questions or clarify anything that's not clear.
Thank you very much, Alex, for that really thought-provoking talk. You covered a lot in that, and I'm trying to think through and imagine what our audience, what kinds of questions they might have. When you started your talk, I felt like you were focused on how long it takes for occupations to disappear. And you were putting that in the context of automation. But two questions. Is that the disappearance that you see there, is that clearly because of automation? And second, how many new occupations are appearing over that course of time? In other words, is there a balance here, or is there a net plus or a net minus? How does that work out?
So the answer is we don't. It's very hard to link those two things together causally. We have a little bit of kind of metadata in that dictionary of titles that sort of has a scale that says something like, this is the degree to which this job works with machines versus people. So we're looking into that to see if we can get a little bit more of a flavor from it. I mean, the short answer is this is very much a data science approach to this problem. So, we sort of work with observing the data that we have. I very much take my hats off to economists, because economists are really good at this kind of causal analysis. That's sort of what they bring to the table. They're able to say, okay, we're going to really isolate what happened in this place and see the trend here and contrast it to this other place where we see something different, and let's carefully attribute that difference to this thing. So that's something very hard to do, but that's a little bit more in the realm of, I would say, the sort of empirical labor economists. But we hope to dig into that a little bit more clearly. I mean, what is true is that over that period, there has been massive technological change, qualitatively different and quantitatively different. So, it's always surprising to see things more or less being the same. And I'm a physicist at heart and by training, and that's what we like. We like when things are universal, because we feel at home there. It's like, okay, gravity works the same everywhere. Jobs disappear at the same rate from decade to decade. Great. So that's what I can say on the first piece. As for the creation of new jobs, this is something that's really not well understood. We know that automation can be sort of net good or net bad. To some extent, all automations, all new technology, they will lead to job losses in general. What happens more specifically is that they are able to automate a certain skill. The demand for that skill goes down, and then it doesn't make sense to pay people to do it, because I can get a machine to do it for cheaper. So let's think about making a chair. One job might be to make the back of the chair, one job might be to make the seat, and one to make the legs. So let's say I can make the back of the chair much more cheaply. So now I can't find people to work for such a low wage to do that. So those jobs have gone. But on the plus side, there's going to be a lot more demand for people to make the seat and the legs, because all of a sudden they're the bottleneck. Like I can make this part of the chair very cheaply. So the only thing stopping me having more chairs is these guys. So I'm going to pay them more to get those chairs moving. So that's kind of a net positive effect that this automation can have. And then generally, directly from automation, you have new job creation. And this is really very interesting. And actually, there's a lot of anecdotes about it, but not really a lot of hard data. But that's sort of this idea that, let's go to the self-driving truck example. sure, a lot of these truck drivers may be out of work, but there's going to be a lot more demand for people who know how trucks work and have domain knowledge about them and can fix them and design them and so on. So there will be a new job created that sort of combines new skills with the sort of old domain knowledge. I can tell you anecdotally from the dictionary of titles that sort of set of occupations, that number is more or less stable. It's not, we sort of have this constant removal of old jobs and creation of new ones. So this sort of ecosystem tends to stay more or less the same size.
Yeah, I was thinking when you were talking about automation risk, that maybe we should be thinking about this as automation opportunity, right? Rather than risk, because it seems to me there are going to be a lot of new jobs opening up that will be taking advantage of technologies that at the moment we can't even envision, right? So it's like sort of seeing into the future, I think gets really tough. I think what you just said, that you would agree with that, because there are so many uncertainties, right?
Yeah, absolutely. I really like that idea of automation opportunity. It's actually very hard to communicate about automation risk / opportunity, because it's very hard, it comes just with so many caveats. There's been a few studies that have tried to assign sort of a percentage risk to a job, and no one sort of really agrees on them. I think kind of the best one is from a guy called Michael Webb in Stanford, and he was able to, through sort of lots of calculations, difficult calculations and magic, was able to look at patents and sort of see what the patents were writing about, and then relate that to actual sort of changes in job numbers some 10 years later. And that's sort of like the best kind of study that we have. We're also sort of thinking a bit about can we sort of model somehow how sort of in the sort of space of jobs, what where a job's going to be removed and where are they going to appear again, and of course are those at all accessible by the same people.
Yeah, no, I think that's a very cool idea, and it also seems to me that the way you're thinking about this is really cool. Remote working and the impact that remote working is going to have on the labor pool and so on, and the types of jobs and so on and so forth. Can you envision modeling that and seeing the impact that might have on the number of jobs or the types of jobs and so on and so forth?
Yeah, well, I've been sitting down doing my best to think this through and talking to a few people who work in actually with workspaces and in sort of smart offices. And they really have an immense challenge right now to try and sort of predict and manage that. I think that probably you will see a stable model of kind of definitely a lot more remote work. I don't think we're going to ever go back to where we were. You'll see a lot more remote work. Not only like I'm going to work from home in the suburbs and then come in 2 days a week, but also this model of kind of a quarterly summit, let's say. So, everyone flies in and sort of has an intense working together and then sort of flies back out again. I would say that we're still a little bit far from sort of thinking about that in a quantitative way right now. So I think we need a little bit longer to sort of see where the cards land, let's say. If you look, the only sense I have from this is Google releases a sort of mobility index where they measure through handsets where people are going and how much they're moving around, and they break it down by sort of different places. And I've been watching each week as they put out these reports, sort of seeing like where it sort of plateaus out. And I think we're sort of starting to see that plateauing. And in places like in Miami, in Florida, where you are, we're seeing that the traffic to workplaces going back to about sort of 70% where it was on average. So I think, you know, we need to wait a little bit longer for the data to come in to sort of feed into those models. But yeah, I think it's going to be immensely interesting to look at mobility, so how people are moving and using transportation. I think it will be interesting from the point of view of kind of labor liquidity, and also kind of how jobs themselves are changing. So in the same way that, as I discussed before, how sort of remote skills are going to be added into the bucket of skills for each job.
The other question I was going to ask in that regard is, you mentioned several times you're trained as a physicist. Did you ever imagine yourself doing the kind of work that you're doing now? And you know, what led you to this passion to be thinking about, you know, the employment ecosystem and how modeling could be helpful for that?
Yeah, sure. Well, the short answer is no. I really never had any idea. I mean, I think as a physicist, you, coming from sort of computational modeling, you have this, you always think about this huge number of molecules or atoms interacting together. So typically you have, like, you know, 1 with 23 zeros, atoms. And, you know, what I always liked is that there's always some way to, like, look at all of that complexity and how those all interact and get out like one or two, like one sort of number that makes sense. So when we think about the temperature of, you know, like a drink, that's what we're doing. We're taking, you know, 1 with 23 zeros and getting out like one number. So I like this idea of sort of, how do you do that? How do you just sort of simplify all of that? And, you know, it turns out that's something that you can really apply to a lot of things. So I've modeled like ethnic violence, constitutional change, epidemics, you know, and in some sense there's a lot that's common between them. But you know, of course, you do have to do your homework and learn what's different between them. You know, in terms of sort of how I came to work on this, there was kind of I would say, like a need, if you like, or sort of recognition that labor markets are very complex and they are susceptible to this kind of data science, complex systems modeling. And labor economics is really a mature discipline. It's been around for a long time. And I think it's, you know, it kind of makes sense that we put as a commensurate amount of resources to how important the problem is. And of course, this is really something kind of defining for our age. So, you know, it really makes sense that you sort of bring to the table new techniques, new methods, new ways to sort of deal with different data sets, let's say. So it's been sort of, I would guess, just like a sort of lucky opportunity that this is something very important that people are interested in. And also that there's kind of a gap, let's say, between, you know, all of the amazing work that's done by labor economists.
Well, here's my final question for you, and this just popped into my head. Have you or any of your colleagues been thinking about climate change and how climate change could impact this ecosystem? Because it seems to me there are a lot of unknowns. I think there are some certainties there, but really understanding how that could impact the economy, the ecosystem of jobs, et cetera, is really something that I think the world needs to understand, right?
Yeah, absolutely. Yeah. So our thinking is very preliminary at this point, but it's really something of huge interest to us. I mean, it's going to be very interesting to see how we can kind of retool what we have for this sort of huge change that needs to come. I mean, I think, I mean, I'm talking to myself very much here. I should really hurry up because it's but, you know, I think we might have some early learning on that from places like China. When you look at sort of the incentives that are in place for developing green technology in China, it's just like orders of magnitude more huge than what's happening in the US or Europe right now. So I think there will be a lot of learning from that, but yeah, we're definitely going to see this huge kind of Keynesian push into green technology. I wouldn't like to put my I wouldn't like to sort of throw my hat in the ring and make a prediction at this point, but there's going to be a huge amount of upheaval, I think. And in general, I think probably we will. I think the places where you can really add value here are going to be, again, like some combination of the old and the new. So, a lot of technology doesn't really have the benefit of a sort of clean palette to work from. So a lot of it is going to be about retrofitting and sort of dealing with what we have and using the technology that we have to, in new ways. So I don't imagine that it will be purely a story of new jobs. I think it will be a lot about how we can retool what we have towards this new objective.
Exactly. Alex, again, thank you so much for doing this. It's been really fun hearing what you're up to and having this conversation about it.
Thank you for having me. It's been my pleasure.
Thanks for watching Curiosity Meets Discovery, research talks from inside the Max Planck Society. Visit mpfi.org to sign up for updates. Follow us on social media at mpfneuro. Curiosity Meets Discovery was produced by the Max Planck Florida Institute for Neuroscience.